Alright, let's look at the homework 2.4, problem number 5. Alright, so I'm going to use GeoGebra to solve this problem. Alright, so I'm going to open up GeoGebra. Alright, here you go. Alright, so first I'm going to type in the function. So f of x is equal to x cubed minus 2x plus 9. Alright, so we got that. And actually, I'm going to make this window a little bit bigger. Alright, now the window is bigger, so I'm going to actually move the scale a little bit so that we can actually see the picture. Alright, so we have that. Alright, and I'm going to just bring it down. Alright, so limit is 13, so I'm going to put the y equals 13. Right, which looks like that. And for first epsilon value, oh, that's not it. Let's see. So for first epsilon value is 0.2. So we're going to go below 1.2 below 13, and we're going to go 1.2 above 13. So let's see. So we're going to put, all right. So you have y equals 13.2, so that's one above, and then I'm gonna put the y equals below, so it's got 12.8, right? So we have that. Right, so it's a little hard to see, so I'm gonna actually try to stretch it out so that we can see it a little bit better. Let's see. So here, right? So that's the acceptable region, and I'm gonna actually stretch it sideways too. So I'm gonna just go here and just stretch it out like this, right, and bring it down. Right, so you can see this a little bit better. Right. All right. So you can see that x equals 2 is, let's see right here, x equals 2. So that's where x is approaching to. That's where it is. All right. Then what we want to do is we want to know these values. So I'm going to look for the intersection. So let's see. So I'm going to use intersect. So go to intersection of these two guys and click. All right. So that's A there, and the other one is these two guys. Oops, no, that guy. Click there, right? So you can see that. Let's see, what's the precision that we want? We want the precision to be 4 decimal places, right? So we have to actually adjust. Let's see, rounding to 4 decimal places. All right. Let's see. Yeah. So we have that, right? Then if you look at this, and here you have B is 2.0198. So it's going to be 0.0198, right? So that's going to be the difference between 2 and this value. So that's the distance here. All right, how about this one, right? So this is going to be, let's see, so you have to do a subtraction. Let's I'm going to cheat a little bit here. So I'm going to go down here. So what's 2 minus 1.9798? All right, so it's going to be 0.202. So you can see that this number is smaller, 0.0198. So the gap on the right hand side is smaller than the gap over here. So I would pick delta to be 0.0198. All right, so let's type that in. All right, 0.0198. Right. For epsilon equals 0.1, we just have to do a little bit of adjustment there. Right, so instead of 13.2, I'm going to just change it to, let's see, I'm going to go down here. Let's see, so instead of 13.2, I'm going to put 13.1. All right, then I'm gonna just change this guy to 12.9. All right, then you can see that the good thing about this system is that once you change this, everything else that's relate to those actually adjust itself. All right, so it looks like gap is now 0.0099. All right, so let's put that in there. So gap is 0.0099. Right? So those are the delta values that ensures that the difference between the function value and 13 is going to be less than 0.2 and 0.1. Right? So let's see if they like this answer. Right? Submit for testing. Alright, it came back and looks like we got both of these guys correctly. Alright, that's it. I hope that this was clear.